Please pause the video and attempt this number properties question before continuing. Okay, so the question says the sum of four consecutive two-digit odd numbers when divided by 10 becomes a perfect square. So we are talking about the sum of four consecutive two-digit odd numbers, and this sum is actually going to be a multiple of 10. Then only we can say that it is divisible by 10, and that results in a perfect square or some other integer, right? So we need a sum of four consecutive two-digit odd numbers such that that sum ends in a 0, because the number that is a multiple of 10 has to end in a 0, right? So what all possibilities do we have when we consider the units digit of such a two-digit odd number? So let's say we're talking about an two-digit odd number, and let's concentrate on the units digit. So what possibilities could we have? So the number could end with 1. The next number, because these are consecutive odd numbers, so next number would end in 3, then 5, then 7. This is one such possibility. The other possibility could start from last digit as 3, then 5, then 7, then 9. Then you could have 5, 7, 9, 1. Then you could have 7, 9, 1, 3. And lastly, you could have 9, 1, 3, and 5. Right? Now, what we need to do is check the sum of these unit digits. If it ends in 0, then that's the case we would be interested in, right? Otherwise, we will ignore. So the first one is 1 plus 3, 4 plus 5, 9 plus 7, 16. So this is not the case that we are looking at. So we will ignore this. So we will ignore this case. This is 3 plus 5 plus 7, 15 plus 9, 24. Again, ignore this. 5 plus 7, 12, 9, 21, and 22. Ignore this. 7 plus 9, 16, plus 1, 17, plus 3, 20. Okay, so 20 ends in 0, so we will keep this case, right? And 9 plus 1, 10, plus 3, 13, 5, 18. So we will ignore this case. So basically, we will keep this case. Now, basically, our four-digit number, our consecutive list of four-digit numbers will end in 7, 9, and 1, 9, 1, and 3, respectively. Now, let's try to solve the question in two ways from here. One possible way is wherein, you can write the first odd digit as x7, where x is the tens digit and 7 is the units digit, right? The next number would be x9, right? The next number will be, let's say, y1, and this y is going to be obviously x plus 1, right? Because, for example, if this x were 1, so this is 17, 19, then we have a 21, right? The next odd number. So this x will become x plus 1, right? And similarly, the next number would be x plus 3. Now, this is not a multiplication sign over here. This is just to show that the magnitude of the number at the tens digit is 1 more than the ones in the first two case, right? So if you look at these four numbers and if you try to, sum them up. So in the unit digit you have 20, as we saw here. So if you sum them up, you have 20. So 0, 2 carried, right? So 2 carried over to the tens digit. So if you add the tens digit now, so x plus x is 2x plus 2 is twice of x plus 1. So 2x plus 2 plus 2x. So 4x plus 2, and 2 was the carry from units digit. So we have 4x plus 4 here. 4x plus 4 in the units digit, right? In the tens digit, right? And you have 0 in the units digit, right? Now, a number which a two-digit number can be expressed at 10 times the digit at the tens place, which is 4x plus 4, plus unit digit, which is 0. So it does not matter if we do not add anything, because it's anyways 0, right? Now this is the total sum of all these four numbers. So 10 into 4x plus 4, right? Now this number, as we know, when divided by 10, so if you divide this number by 10, we get 4x plus 4, which is, if you take 4 common, you have x plus 1, right? So 4 into x plus 1 is a perfect square. Okay. Now, what are the ways in which this number can be a perfect square? So if you look at this carefully, 4 is already a perfect square, right? Now we are going to multiply another number to it, right? So the other number, in order for the entire number to be a perfect square, the second number also needs to be a perfect square. So what are the possibilities for x plus 1? So x plus 1 can take the following values. Either x plus 1 can be 1 or 4 or 9, so on and so forth, right? So for x plus 1 to be 1, x has to be 0, which is not possible given the answer choices in which we are operating, and also the fact that x equal to 0 will no longer keep the numbers as double digit numbers, right? So we'll go into single digit numbers, right? So you can ignore this possibility, right? You can ignore this possibility. Okay, for x plus 1 to be 4, x has to be 3, right? So if x is 3, then the numbers that you have is 37, 39, 41 and 43, right? Which basically means, if you look at the answer choices, choice C contains, so the list contains the number in the choice C as a number, right? So which means option C is definitely going to be our correct answer, right? And obviously if you take x equal to 8, you will get x plus 1 is 9. That is also a valid solution, but that is not in our answer choice, so we can ignore that, right? So on and so forth. Okay, so this is one method from here. The other method is to directly work out from answer options. How can you do that? Let's look at that. So once we figured out that this is going to be our case at hand, right, desired case at hand, what we can do is we can work out from answer choices. So if you look at choice A, right, so what is this number going to be? So if choice A were true, then one of the numbers is 21, right? Which means the preceding numbers are 19, 17, and the next number is 23, right? Now if you add these up, what do you get? If you add these up, you get 4, 6 and 8, 80, right? Now when you divide it by 10, you get 8, right? So you get 8, which is not a perfect square, so you can rule this out. 25 is not going to be correct because 5 does not feature in the list of these items as units digit, so 25 is gone. Okay, in case of 67, if you look at 67, what are the possibilities that we have? We have 67, so 69, 71, 73, right? So if you sum them up, this is 0, this is 2, 12, 14, and 14, 28. Right, so now if you divide by 0, we have 28, which is not a perfect square, again gone. 73, if you look at 73, you would need 67, 69, 71 and 73. This is exactly the same list as this one, therefore this is also not going to be correct. So the only choice that you are left with is 41. Let's test that out. If you had 41, then the list would be this list, right? Let's try to sum that up. So if you sum that up, this is 0, 2 carried, 6, 2, 8, 8, 8, 16. If you divide this by 10, you get 16. and 16 is a perfect square, and therefore choice C is the correct answer. So you could do this question in both these ways, and there exists at least one or two more ways to solve this question. The idea is to spend more time per unit question and try to figure out all possible ways or maximum possible ways of solving that question. Okay, thank you.